Well, shall we?
Yeah.
Well, good afternoon. There's still a few seats left at the front. Thanks for coming here to the last session of the conference. Has it been good for you?
Yeah.
It's been great for me. I've been to this is my fourth Ignite. I haven't really liked Ignite until this year. I thought they kind of nailed the logistics this year, so quite happy about that. But yeah, thanks again for coming to our session. We're talking today about turning your social communities into knowledge-based communities. And to do that, we're going to use a combination of products. You'll see them all in here. But we're essentially going to be injecting some machine learning into the mix. And it'll be fairly demo-centric, certainly for the latter part of the presentation. I better help, thank you. So just to get started, by way of introduction, my name's John White. I'm Canadian. I'm from Canada. The jokes don't get any better. I'm the CTO and co-founder of a company called Unlimited Viz. We are the ones who make tygraph. You see the label on the shirt. I don't know if you've seen the Twitter analysis that we do for basically for the community for Ignite. You're going to see it today a little bit. But we do that as well. I am personally an Office Apps and Services MVP as well as a data platform MVP, which means a SharePoint MVP and a Power BI MVP in the short. That's my contact information up there. Please feel free to reach out to me with anything as we get going. But I also want to encourage, we're a small group, I would like to encourage you to just ask questions as we go. I would encourage you to go up to the mic and ask them, but if you don't, Dean's going to remind me to repeat the question.
I am.
And we'll answer them as we go through it. It's kind of meant to be interactive. We figured we'd be here at the end of the conference with a small crowd. And if we don't have much interactivity, we might go home early. So that's up to you. That's me in the picture. That's doing what I like to do when I'm not doing technology. It also explains my rather weird Twitter handle. So now you know what I like to do, and you know how old I am. Anyway, and at this point, I'm going to turn it over to Dean.
Thanks, John. My name is Dean Swan, and I'm with tygraph2. I'm the Director of Product. That's me in the corner. I like to travel. That happens to be in Dublin. So again, I want to extend my welcome to you guys for coming today, sticking it out, being here. It's very much appreciated, and we'll get going. So we're making the case for knowledge communities. Who's seen this? Does this resonate with you guys? If our company only knew what our company knows. Now, this is a real common refrain. It's overheard in lunchrooms and break rooms and boardrooms all over the globe. It's too common, really. Now, I've tracked this statement back to IBM in the early 70s, but I heard it myself just a few years ago, and I'd like to share a story with you about that moment. This is a true story, but like a lot of those stories, there have been some changes to protect the innocent. I had my own awakening to knowledge management while I was working with a large agribusiness in North America. It's a big company that's in the food business. They have products and services. And one of those products is salt. And there was this guy named Bob. And Bob was the salt king. This guy knew everything about salt. If you had a question about salt, call Bob. You wanted to put your hands on some research for salt, give Bob a call. This man, he knew that there were 14,000 ways to use salt. He knew that only 6% of salt's really even food grade. Bob just knew, but he knew a lot more than that. But no one bothered to capture what Bob knew. And then one day, poof, Bob was gone. His colleagues, including me, were saddened by the loss of Bob. And they were saddened by the fact that they reflected everything that Bob knew. They didn't know. Oh, hang on a second. Sorry, Bob wasn't dead. Sorry about that. He didn't die, he just retired. And when he retired, all that knowledge in Bob's head walked out with him. This is a big issue in our world today. A lot of baby boomers are retiring, and the knowledge that they have are walking out with them. This left a lament with me that left a huge impression that I've never forgotten, and I'm going to share it with you. Corporate amnesia is a real thing. It is. So one of the chronic symptoms of corporate amnesia is that knowledge is sticky. Now that's a little phrase, but let me break it down for you. What I mean by that is knowledge is tough to move it from one place to another. It's hard to move it from Shona's brain to James, and then from James to Abby. It's very hard to do. Now, communities, social communities, they help us do this, and they can help this issue quite a bit, and they're critical in helping to address this. According to APQC, communities are important because they nurture and harness that raw material of the millennium, which of course is knowledge, to help serve the organizations where we work. Now, I mentioned APQC. They are a nonprofit organization, have been in business for a long time, that provide quite a bit of benchmarking and really good stuff. Some of what I'm talking about is in a book called The New Edge of Knowledge by Carla Odell. If you don't want to buy the book and you're you're here, in the SharePoint community, there's a terrific champion of KM. Her name is Susan Hanley, Hanley. She did a number of sessions here this week. If you want to look her up as well, you'll get some great knowledge management information. Now, lucky for us, we're living at a time where we've got some technology, some social communities that help us. Now, I get that Teams and Yammer do other things, but bear with me, and Twitter, we know what that is. But these social platforms are allowing us to get our social knowledge captured, and that is being supported by these two technologies, SharePoint and OneDrive, working hand in glove with our social platforms for good. And these moves of knowledge are being orchestrated with flow. And two rising stars on the scene, Cognitive Services and Azure ML Studio. Now, the way I like to think about this is all this stuff, all of this, John's going to show us how he put it all together, and I like to think of them as knowledge droids. One of the reasons why I like to think that is because I've always wanted to stand on stage and say, these are the droids that you're looking for.
I knew where you were going with that.
Thank you. Thanks for bearing with me, folks. Okay, so the solutions we're going to see today, the first thing John's going to show you is a sentiment analyzer for Twitter. You'll recognize it if you've seen any of our Twitter statistics, tygraph for Twitter. Sentiment analysis, some people call it opinion mining. A business application for that might be, let's say you're a customer-facing organization, you've got a product in the market, and you're doing some social media support. This, getting a sense of what the sentiment is on a hashtag that's following that campaign around is very helpful. We're going to show you an image analyzer called computer vision. We're going to use Teams to do this. John's going to throw a bunch of pictures at the engine. It's going to spit back attributes that it figures out about those pictures, and it's going to put that in Teams, and then you can have conversations about those pictures and those attributes. A little twist on that called the custom vision. We're going to analyze some images that John trained with specific attributes that match my business case or a business case. I'll give you an example of one. You could use something like this to take pictures of safe and unsafe conditions, train it which one of those are, and then use that to spawn conversations around the importance of safety. The fourth thing we're going to do is John's going to show you a group-based question and answer solution for Yammer. And this is something that's going to improve over time. Imagine being able to take all your vetted questions and answers, put it into SharePoint, and then serve those answers up when somebody asks a question into Yammer. Now, here's the cool thing. If the machine has low confidence or no confidence, it gets kicked over to an expert who answers the question, and that gets added too. John's going to go into that in a lot more detail, but that's our fourth solution we're going to show you today. And then finally, a solution that automatically hashtags Yammer messages based on the content. A business application of this could be something like an ideation campaign, where you're building on previous campaigns that have been with messages that have been hashtagged. Now, before we get going on this, John is going to walk us through some machine learning.
Some machine learning concepts, that's right. Thanks, Dean.
Yeah.
Much appreciated. So as I mentioned before, we're going to be leaning on machine learning to do some of this stuff. So we want to get into something like, I was going to put up machine learning for dummies, but I didn't want to do that. So machine learning for people in a hurry. And I just want to get across some of the concepts of machine learning. You don't need to know, one of the big concepts I'd like to impart today is that you don't need to know how to build all of this stuff. You just need to be able to use this stuff. You don't need to know how to generate electricity to turn on a light bulb, although in some cases it may come in handy. And so I'm going to go through a number of the examples that Dean just pointed out, basically rank in order of increased complexity, but you won't see any code here today either. So to start out with, what is machine learning? Because it's a bit of a flavor of the year. You know, it's the hot term. That and artificial intelligence, which are not the same thing. And you'll notice I'm avoiding the use of the term artificial intelligence here. It's because it's a particular type of machine learning. And I always like to go to Wikipedia for definitions of things and then make fun of them on stage, but I couldn't really do it with this one, because I rather like the definition that Wikipedia has for machine learning. It's pretty much true. The key here is that the system itself is going to learn from data, so it's data-driven, and it's going to progressively improve over time. So it's going to iterate, okay? So those are a couple of important points in there. To start with, you have to have a fair bit of data, or someone at least has to have had a fair bit of data. It's not new, right? We've been doing statistical analysis for years and years and years. And a lot of the models that you'll find in machine learning are based on these, traditional statistical models. Linear regression is in there, all right? And that's something, nonlinear regression is something that I used back in 1988 for my undergrad thesis on a SAS mainframe, et cetera. That's fairly old. I was interviewing Amanda Kofsky for a podcast the other day, and we were asking how she came to the Power BI team and what she was focused on. She was talking about how pervasive PowerPoint is and how she was using it in high school, and I had to remind her that I was using punch cards. Again, machine learning is any system really that improves itself over time, and AI is different. AI is a type of algorithm you use that doesn't use statistical analysis. It finds paths through data and to find, basically to find an endpoint. So you can do some of the same things with it, but it's a different approach completely. And the other important thing here is you don't explicitly program these things. You build enough data, and then you let it figure what the right path through the data is. We'll get an example of that here in a second. Why do we want to use this? Because I love this quote, right? This is originally attributed to Mark Twain. The best predictor of future behavior is past behavior. It's usually applied to psychology, but it's also true of data. I'd argue that it's more true of data, because for data to change, something fundamental has to change. When you're dealing with it in psychology and people, they can change their behavior at any time for no apparent reason. But I'm not bitter about that. I think I've gotten over it. We're going to want to use something if we don't fully understand the rules that help a system operate. In a lot of cases we do, and in traditional programming we understand how things are going to work, and we have to explicitly program it. If this happens, then we do that. We follow this path, etc. Let's look at it let's look at it by means of an experiment. If we talk about something as simple as traveling through space, over the ground, where we go at a consistent speed, we go for a certain amount of time, we can figure out how far we've gone, right? We know the equation that's involved there. Distance equals speed times time. And, you know, projecting this out as if it was a theory, we can test that theory, right, by actually performing the experiment and plotting those points on a graph. And if we do that, it might look something like this. We don't follow the line perfectly, right? We might have errors. It might be because the person didn't have their foot on the gas exactly the right amount all the time, or they were forced to slow down, or we have measurement errors, whatever that is. But we can actually use statistical techniques to tell us that our theory, in this case, was correct. We started with a theory. So we'd use statistical analysis to verify what we thought in the first place. With machine learning, and this is kind of traditional programming, with machine learning, we turn that on its head. We say, we don't know anything about the underlying system. And instead, we just plot a bunch of points. We just collect the data that we have, and then we apply some sort of an algorithm to it to figure out what the rule is and derive what that equation is. In this case, we're applying a simple linear regression. And a linear regression aims to minimize the deviation, the distance between any of those points and the line itself, right? At the end of the day, we come up with the same, in this case, in this very simplistic case, we come up with the same result, but we went about it a different way. And this, of course, has a lot of value if we're dealing with highly complex systems that we don't understand. Make sense? Right? Okay. So, when do we want to use it? Well, obviously not to calculate distance over time. We have a pretty good handle on that stuff. But when we're dealing with poorly, or highly complex or poorly understood system, we do. Like taking a corpus of data, a document, and figuring out what that's about. Or when people say things, what is it that they really mean? That's the sort of thing we're going to want to use machine learning for. One of the criteria here is we have to have data available, because the first thing we're going to do is train our model. We're going to calculate what that line was or whatever the mechanism was. We need to train it, and we have to have lots and lots of data available. The more data, the better. The more accurate we're going to be. Now, we also clearly have to have a tolerance for uncertainty. We're probably not going to be 100% certain that a system that was calculated by means of regressing back from the data is going to be 100% accurate. But it'll probably get us in the right area, and that's going to be good enough for us. And we have to have a well-defined problem. We have to know what it is we're looking for. We can't just throw a whole bunch of data out there and say, can you find me something interesting? Although the Power BI team's doing some interesting things in that area, but for the most part, it's like, yeah, I knew that already. So we can classify, break apart machine learning systems into effectively one of 5 categories or algorithms. They're typically used for anomaly detection. Again, based on when I was growing up, immediately it comes to mind, one of these things is not like the other. I'm not going to sing it. But this is the type of model that you're experiencing when you go on a trip and your credit card gets declined, right? We love this stuff. But it's meant to detect outliers, things that don't belong, and maybe we should bring our attention to it. Related but not the same thing are clustering algorithms. Clustering algorithms are how you put data together. So this data would belong in along with this other data over here. You might combine it with one of the algorithms coming up as well to get more information. Regression, I kind of showed you the basics of a regression type algorithm. You're going to use that for predictions. If I put these series of variables in, what is my expected output? All right? And regression can come in many, many flavors, but that's basically its idea. And then we have the 2 classifications. There's a 2-class classification, essentially a true or a false, when our outcome is this is either true or it's false. We can give this person credit or we can't give this person credit. Versus multi-class classification, where we have a fixed series of categories for something to fall into, and we're going to let our machine model, learning model figure all that out. Now, I know I'm going down the rabbit hole on ML, but again, trust me, you're not going to need to understand all of this stuff unless you want to. And if you do want to, there's a handy-dandy cheat sheet here. And this is from Azure Machine Learning Studio. And it essentially is articulating what I was talking about. See that big yellow ball in the middle? That's where we start. And this helps us figure out what algorithm we're going to need. And that's really one of the only hard parts of building a machine learning model, is figuring out what the right algorithm for the job is. But if we look here, we hit start. And in our example today, we're going to be figuring out from a Yammer message what category it belongs to. And it's a large set of possible categories. So we're going to, first of all, what we want to do is to predict a category. So we're going to go off to the right-hand side there. And our options are either 2 or multiple. So we're down immediately to 5 possible algorithms. And for the most part, it's trial and error as to which one you're going to want to use. If you look at the entire cycle of a machine learning system, it starts with the data. You're going to need data to get going, so you've got to gather it and prep it. That's the biggest job. Getting your data in the shape you need it to be is always the biggest job of any machine learning project. Then you go ahead and you build and test the model. And that takes several iterations and it takes some time, but the tooling, again, in Azure ML Studio in particular, is fantastic for this. It's totally geared for this. It's like SSIS for machine learning. You deploy it, you run it in production, and then periodically you check back and take the new data and run that back against your training model and improve the model over time. Again, we come back to that principle of improving it over time. Our counter's not working.
I've got one.
Yeah, just to point that out. Anyway, now, like I said, you don't have to build all these things yourself all the time. The reality is there's a lot of stuff out there in market that lets you use machine learning. And I classify it into 4 essential buckets. We can use built-in machine learning, which are, if you look at some of the things that were released today, or this week, sorry, Office Ideas, I think is what we're calling it. Office Ideas is a built-in machine learning capability. It just shows up in your product, and you don't need to know how to use it. If you see the transcription that's going across on the top of the screen, that's machine learning right there. It's calling into a speech-to-text recognition algorithm, and that's part, or at least it's an add-in to PowerPoint today. You can just install that and use it. You don't have to do anything. And then there are services that are there ready for you to call into, and we're going to see a couple examples of them today. And they are typically, the ready-to-run services have already been trained. So they do a specific thing, and they've already been trained. They're just ready for you to throw something at it, and it can tell you what it thinks it is, all right? Now, that's good in a lot of cases, but it may not be good in every case. You may have some specific requirements. Well, that's okay, as long as it matches up with some of the services that are out there that do a certain thing, but they need you to tell it a little bit more about what you need. For example, categories. That's fine. You can use Microsoft's model, but you can train it, and there are techniques to do that, and we'll see that. And then finally, at the end of the day, if there isn't a service out there that does what you need to do already, you can use this Azure Machine Learning Studio to build your own machine learning model. From a product standpoint, we're dealing primarily here with Azure Cognitive Services in the Microsoft world, and there are a whole host of these things that are available. Computer vision is something you'll see an example of today in the ready to run. Some of the product categories fit into both types, ready to run and configurable. So computer vision is a ready to run, and it can go out and try and figure out what's in a picture, or it can do handwriting recognition, etc. You can do similar things with video, face recognition, or in this case, face detection. I can tell that there's a face in a picture. I can tell if that person is smiling or not, what the sentiment is. Speech to text and text to speech, again, the example I pointed out here. And text analytics. Down at the bottom, you see sentiment analysis, and that's a pretty commonly used one, and I'm going to show it to you here in just a second. And then text translation, and translation into multiple languages. And we have the configurable service. custom vision. Again, that's like machine vision or computer vision, but this is using your own data set to do training. And it goes out again, face, well in this case it'll recognize whose face that is, if there is a face. And you can pile one on top of another. And I'll call your attention to Q&A Maker down at the end, because that's another example we're going to be using, which is a new type of knowledge base that you can build and consume. And with that, I think we're into demo time. Not yet, yes. So, all right, so we can flip over. It's number 8, I believe.
Yep.
So to start with, I'll put this down. Make sure I'm going to the right spot. No, not that guy. Not that guy. Oh, wrong one. Okay. Yeah, the right screen up.
There we go.
This is the Twitter monitor I was mentioning a little bit earlier. And we do this. It's a community service from tyGraph, and we'll monitor tweets for any given event in the community. Ignite is no exception. So for the last month, we've been monitoring the MS Ignite hashtag, and you can see what the results up there. It's kind of impressive. Over 1 billion impressions, about 113,000 tweets so far. But if you look down here in the bottom left, you can see sentiment. And the way that this works is each tweet gets its sentiment analyzed. It might be going. It's been a long week. Has its sentiment analyzed, and that's stored in a database. And we're aggregating all of that data. So you can see that Ignite had a 0.66 sentiment rating. That's pretty high. It's not as high as the average for all of the other events we monitor, because that's what that little target line shows you. But you can do things, of course. This is a Power BI report. We've got a second page here, hashtags and mention. And you can also see things like what the top topics were for Ignite. And because it's Power BI, I can, of course, click in on anything. So I can say, here's Teams. Teams came in at exactly 0.66. Here's SharePoint, and the number 2 most tweeted came in at 0.69. And Azure was about 0.63. So that's, people are talking about it, and what's the sort of thing that they're saying. Okay, how does it work? It's fairly straightforward. I'll get into the architecture for all these when this all concludes. But if I come down here, and I come over to flow, basically we're gathering these tweets with a flow. And if I open up this one, TG Twitter capture for MS Ignite, this will be the last one that ran 40 seconds ago. It succeeded. I'm just going to open it up. And you can see we've got, it's a simple flow action, right? You can see when a new tweet is tweeted, or is posted, you can open it up, and there was the tweet. Someone was going to Dan's session, unfortunately. That's why there's nobody in here. Yeah, no kidding. We simply fire off, for this particular tweet, we fire it off to the sentiment analysis. It's an action in flow, and we got back a pretty high sentiment score. Dan's getting a 0.95 sentiment score for that particular tweet, so that's not too bad. Yeah, and then when we're done, we insert that row into a SQL table, okay? Very straightforward. And so you should be able to see here, this is just SQL Server Management Studio that's running when I hit execute. Whatever, I'm not sure if that's the same one now, because it'll sneak in time. But basically, here are the details, and that's the most recent tweet. So we're just storing this in SQL and reporting back on it in Power BI. So unlocking machine learning is as simple as that, using a flow action at one level, right? Something anybody can do and add value to their system, to their network. All right. Let's move on to the next one. With the next one, we're going to start in Microsoft Teams. And I'm going to move down here into Teams. Just one second here. Oh, shoot. I'm going to go into our demo environment. There we go. And I go into images. And if I come over here to image tagging, what I'm going to see is the content of a SharePoint library. Actually, it's specifically an image library. You do that, by the way, by adding the tab into Teams with this plus icon and using document library for most SharePoint libraries. This is an image library, so there's a little trick in doing that. You actually use the, if you're interested, you use the web action, and you just punch in the URL to that library, and it'll light up, though, all of the SharePoint capabilities that are in that library. Now to get started, so what I'm going to do is I'm going to put images in there, and I want the system to tell me what's in those pictures, okay? So I'm going to call into a service that's called, where are we here? Computer vision. And you can try it out for yourself right here, right? You go to the web page for computer vision. Here's an example of how of this picture being sent up. If I want to try it out, I'm just going to browse out here. I'm going to go to not that guy yet. No, we're not going to quite get it. We're just going to upload a picture of an apple. And there we go. Just by doing that, it's come back, and if you can see, I'm going to try and zoom in on it. Okay, so zoom it doesn't work so well. All right, but you can see here we've got some of the tags that came back with indoor with a confidence of 96%, apple with a confidence of only 40%, but it got it. Sitting, food, table, apple, photo, etc. And it actually gives you a caption, a close-up of food. All right, that's something, right? Now, how do we tie that into our social network? Well, first of all, let's go back to Teams.
John?
Yeah.
I just want to see a show of hands. How many of you guys are already using Teams in your organization?
A lot of them.
Oh, good. Okay, great. Good. Thank you.
That's cool. And by the way, this is kind of fun. Has anybody ever noticed that a cut apple looks an awful lot like a barn owl? Right? Here, I'll show you. A cut apple looks a lot like a barn owl. Can't zoom in on it. And the idea here is I've cut this image up into individuals to see how well this works. All right, so I'm going to throw all these pictures into that library and see what it can do. All right, so let's go into this library here in Teams. I'm going to upload. I'm going to upload a series of files, and we're going to see those pictures here in a second. But if I go into the owl or the apple, I'm just going to select all of them except the composite and click on Open. Now, as that uploads, and hopefully it's fairly quick, I'm going to go back into Flow. So if I come into Flow, I'm just going to change my environment because the rest of things are running in demos. All right, to start with, we got this flow called Extract Image Properties, and I'm going to go into the edit mode so you can see what's going on. I'm not going to dive into the details here, but to start with, we're using a SharePoint trigger action. Because as you know, SharePoint is the storage mechanism for Teams, and it's about to be completely the storage system for Yammer as well, but it's an optional storage system for Yammer right now. There's a second step we need to do when a file is created in a library. We need to get its ID. So if we have its path, we can get its ID, and that's a simple action by basically creating a flow action and passing in the file path to a particular URL. Straight up, very easy to do. And then we just call this function for analyze image. And we're calling in the computer vision service, and I'm going to use the content of the file that was stored in SharePoint. And then I'm going to do some variable manipulation just to store these as we go because we're returning multiple tags, and I want them returned in a string with commas, etc. And then we go and get a caption, and then we check to make sure that the tag was actually successfully read. Otherwise, we won't write that out. And if it was, we go ahead and update the file properties. So we literally update the tags in SharePoint, some of the fields in SharePoint, and then we go ahead and post a message to Teams saying that that file has been uploaded. So with that, we should be able to flip back to Teams. And we can see that's what's happened. So the title of this image is a close-up of a fruit, and you can see it's got the keywords of indoor, fruit, and apple. Close-up of a fruit, fruit and apple. Close-up of a fruit, fruit, indoor, apple. It's got an apple almost every time. It missed this one. But it's done okay. It's got sliced, etc. And then we come down to the owls. Close-up of an owl, owl, bird of prey. It missed this one, didn't get anything. An owl, or it maybe hasn't returned this one yet. An owl looking at the camera, etc., etc., etc. It never got it wrong. It may not have figured it out, but it never got it wrong. So if I go now and search anywhere in SharePoint, for owl, I'm going to return all of these pictures. And I didn't have to do anything to tag it. So at the very least, it makes it an excellent starting point. Remember, you have to have a little bit of tolerance for error. And if we come back over here to the conversations for this Teams channel, you can see John White just added an image of a brown and white owl. It has the following tags: owl, bird of prey, animal, bird, white, etc., etc. No code, simple as anything, right? Cool?
John, a couple things. So with computer vision, it is comparing the images you gave it to the known universe of
Correct.
all images, right?
Yeah.
Microsoft has collected.
Yeah, and there's a way you can run that. For example, if you were, say, a tabloid, and you wanted to automatically tag pictures of celebrities, they've got a model that does that for you too, or landscapes, etc. But in this case, animals and owls, and et cetera, et cetera. So yeah, that's kind of fun. But what if you don't have something that's specific to your domain? All right. Well, there's another service called Custom Vision, and here's how that works. If I'm going to pop over here to Custom Vision, if I can find it, there we go. That's the service Custom Vision. So Custom Vision allows you to upload, in this case, pictures or images, a set of images that you use, and you can tag them however you want. And just to be in the user interface, I've uploaded a few pictures of my two youngest boys. That's fairly safe. And there's some pictures of them. And they're named Marcus and they're named Ian. All right, so here's a picture I'm going to select, and it's got, I could have added dog as a tag here, but that wouldn't have helped us any. So Ian, kids, and Marcus, right? And here's Ian. There's a picture of Ian. That's great. And he's tagged appropriately. And there's a picture of Marcus. And as long as you have at least 5 incidents of any tags, you can see I got 5 of Ian, I got 6 of Marcus. I should be able to upload now a picture that has one or the other kid in it, and it should tell me if it, which one it is. So I'm going to go ahead and do this. I'm going to go over to Quick Test, and I'm just going to browse my local files. I'm going to go into my kids folder, into the test area. And here's a picture of Marcus that is not in that corpus. I'm going to select it. And if I open that up, there it is. And I just, boom, it comes back. You can see kids with a probability of 99.7%. It nailed it. Marcus, 99.4, and Ian, 0.6. So those are our tolerances, right? So that's how it works. And you can, once you've implemented the service, you can just consume it that way, but that's not that interesting. What's better is to do it within the context of the social network, right?
Right.
So, in that case, and I've got a little more interesting, I think, a demo from that standpoint. I'm a diver. You saw that at the beginning, right? And I went on a trip in 2011 to a place called Wakatobi in Indonesia and took a bunch of pictures. Well, I fed those pictures now into this model. And I was lucky enough to go back a few years later to a different part of Indonesia, but similar animals. So I thought it would be interesting to train a model with the one to see if it could detect the presence of the animals in the other. And it turns out you can. So I'll just show you another example. That is a bubble coral shrimp. You can see it's tagged with diving, scuba, shrimp, and underwater. And then there's this guy. Technically, he's a flatworm, but I'm grouping them together with nudibranchs. And it's a type of cute underwater slugs. There's lots of them there. So you can see there's nudibranch right there as one of the tags. Otherwise, it's diving, scuba, and underwater. And just to show you some of the diversity there, it's a hot topic this week, here's another type of nudibranch, right? So I'm going to then, so I've gone ahead and trained that model just literally by hitting train. The green train button is how hard this is. But I want to test it out now. So I'm going to do a quick test against a nudibranch, but from the other trip. So I'm going to go ahead and browse local files here. Go back, not kids, pics, but if I go down to Raja Ampat was the place I was talking about. And so here's a nudibranch. So I'm going to select it, and I'm going to, I don't want to do it here, sorry. I'm getting ahead of myself. That's the training. What I wanted to do, sorry, is to come down here and back into Teams and come down here into my Teams diving channel. So if I go over into my diving pictures, you can see I've got a couple of other images in here that has been detected. I'm going to upload that one, the one I just was pointing out. And I'll do the same thing with pics, Raja, the nudibranch, and open. And I'm going to upload that. And while that's being uploaded, I'll flip back over here to flow. There he is uploaded, and that's going to fire off of this flow here in a second. What does that flow look like? And I'm not going to keep that. Go back to my flows. And this is the diving, categorize image and get keywords. I'm going to go into edit mode on this guy. And you can see it's the same beginning steps. Go and get the ID of the item. And then the action is really the only different thing in here. Each one of those custom vision projects get a GUID, so all I have to do is punch in the GUID, and then I pass in those file contents, and it's going to go ahead and use that project for the sample. But same sort of idea here, some variable management, go ahead and update the file properties, and then post that message back into Teams. So now, if we've allowed enough time to elapse, and we haven't, that metadata should get updated. Let's just give that a second. Yeah, it just hasn't fired. So what's going on is Flow will see the item uploaded or the image uploaded in the SharePoint library and kick off. Just not quick enough. I normally go through that explanation a little bit slower.
There you go.
There it is. There you go. So it shows up with diving, underwater, scuba, and it picked Nudibranch successfully out of that list, right?
Pretty
Fairly
cool, eh?
right?
Yeah.
And you can do that yourself. There's no code. No code involved. Let's do a different example. And we'll switch gears and we'll use Yammer for this one. All right? And so for this one, we've got a group here called Ask Us Anything. And the idea is I want to be able to take some of the workload off the people who are answering questions. It's sort of like the idea of a bot, but in the context of a social network. So I want, when someone asks a question in my network, if we already know the answer, to Dean's points earlier, I just want them to get answered. I don't want to have to bother anybody. But at the same time, if that answer is interesting, I want to be able to capture that and add it to our corpus of knowledge, all right? So I'm going to go ahead in here and punch in something like, and I've got these, so you don't have to watch me type. I have some of this stuff already here. So I'm going to go ahead and punch, where is the washroom key, all right, as a question. Now, to start with, I have a SharePoint list. It's in the same site that's underneath this Yammer group. And you can see there's a number of questions and answers in here. What year was TyGraph launched? 2013. Where is the key to the washroom? Which is similar to the question I just asked, oddly enough, right? What this is an easy way to get people to enter questions and answers. But it isn't providing any of the service ourselves. There is a service in Azure, I called it out earlier, called Q&A Maker. And Q&A Maker, well, what happens is when I add an item to the SharePoint list, a flow runs and adds the item to Q&A Maker for me. And Q&A Maker is over here, and it looks something like this. This is one of my knowledge bases, right? And a knowledge base can consist of multiple sources. So in this case, it consists of this Ask Us Anything list with some ad hoc questions and answers. But it's got a different source. We actually uploaded one of our data dictionaries. This is, again, proof of concept, to the service. So it's got a question, or basically a variable, or some aspect of our product, and a definition for it. So if anybody happens to ask a question about the product, they'll get an answer. And you can see there's that where is the key to the washroom sitting right there, all right? So that's fundamentally how it works. I'm going to pop back over here into Yammer just to see if it's run. Yep, there it's run. So you can see immediately, where is the key to the washroom? It's hanging behind the door of the janitor's closet. I didn't ask the same question, did I? Right? That's because the Q&A service isn't just doing a straight lookup and return. It's leveraging the language understanding service from Azure underneath the covers. You don't care about that. You don't need to know that, but that's what's happening. And so that's extracting meaning from my question. So I can get on the fringes. They don't have to be asked in exactly the right order. That's kind of cool, right? Yeah. You know, right away, a live Q&A system. But what happens if the question isn't already in there? Or what happens if the model isn't sure of what I was asking? Let's grab a different example of that. If I come in here, I'm going to ask, what is the report period? Now, actually, I'll go ahead and do that. So that would be a question about our product. We have a artifact called report period. What does that mean is essentially what that is about. So if I come back over here to Q&A Maker, I'm just going to type in report period just to see what is in there now. And you see it gets returned. Report period, here's the answer. A visual aid designed to be added to blah, 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 right? But it's just in there with the word, not what is the. Let's see how well this guy does, and I hope it fires in time.
And while you're doing that,
Yeah.
John, just to go back to the previous example where you asked a question and you got a response pretty quickly, a lot of what we're talking about is automating some processes that normally a person would do. So if you're asking a question that already has an answer and you're able to return it quickly, you're reaching one of your colleagues in a very teachable moment, and they're not waiting for a human to come answer that question. So that's one of the benefits of starting that right away. And you're going to show us what happens now when...
Exactly. So you can see what's happened, right? It's come back and said, we're not really sure about this. We're going to go check with an expert. I happen to be the expert. So let's see what my experience is. So again, we're using flow at the background. If I come back to flow, flow has this concept of approvals. There's an approval action, all right? So there's an approval sitting there waiting for me. So when an approval action hits, I get an email. I'll have received an email if I was running my email. We're not going to go into my email and have a look at that. You can also get a notice on your mobile phone. I don't have it plugged into the screen, so we don't see that. So I'm going to go to my notification center in Flow. It's exactly the same experience in all three different medium. You get this card with content in it, and you can see I've got a Q&A answer. Approval is required. And the top-ranking answer to the question, what is the report period? A visual aid designed to be added to the report at the discretion of the user. That looks pretty good. I'm going to go ahead and approve that. And confirm. And that's it. So now, if I go back to Yammer, we can see there's the answer. Here's the answer. A visual aid, blah, 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 blah. But more importantly, what's happened? If I go back over here to Q&A Maker, and I may have to refresh the page. I think I have to refresh the page.
Yep.
So I'm going to go ahead and do that. It just takes a little too long to load in for my liking. Cool, huh? All right. So now if I punch in report period, there you go. We've got the original term that the service hit on but wasn't confident about, but now we've added that specific question in so that the next time someone asks that question, it will just go straight and get it answered, right? Cool. Right. Well, what happens if something's completely wonky? Let's go back again to Yammer, and let's ask something like, I don't know, how far is up? This one I don't have canned. And I post that question in. Now, you get the general idea from a Q&A maker's standpoint. I'm just going to take this opportunity to show you the flow that's behind this. So there's the Ask Us Anything answers. I'm going to go into edit mode on it. It is already running. But you can see when there is a new message on a group, that's a trigger for Yammer and Flow. And I check that the message ends with a question mark. Right? Is it a question? Otherwise, we don't want it to run on answers. Right? And then it will go off and generate an answer, which is just calling into the service, the knowledge base ID. And then it basically goes in, checks the confidence level, and if it's above a 0.9, it will go ahead and answer it directly, and otherwise we go through this whole approval process. This gets a little bit longer depending on the chain you happen to go down, but there's that approval process step I wanted to show you. But in the meantime, if I come back over here to approvals, I'm the expert. It wasn't able to find, trust me, it couldn't find the answer to how far is up. It wasn't in the system. I'm going to go ahead and look at this, and it comes up with the answer is the date of the last activity made in the site. Nope, that's not it. So I'm going to reject it. What's that?
Not even close.
Not even close. So I'm going to say pretty far. And go ahead and confirm it. And now that that's been done, we should be able to go back into Yammer, see that temporary, how far is up? We're not sure about this one, and here's the answer, pretty far. But if we come back over here to our SharePoint list, there's how far is up, and it's pretty far. And you can imagine, as long as it's run, and I hit F5, or hit the refresh button, so bear with me on the refresh. Just want them to improve the performance of this part of it, but I'm an admin in here, so it doesn't really matter. As long as it works, it's quick enough to use. So we should see how far is up down there as a question, pretty far as an answer. That's become part of an organizational corpus. This is obviously a simple example. You might put multiple layers of approval on it, but the idea here is we get that answer back to the user as quickly as we can. We don't bother our experts any more than we need to, and we're building our organizational knowledge. We're using machine learning in a machine learning way, right? We're using the language understanding service, which is machine learning on its own, but the process, it's not a product. Our process that we just built is machine learning, right? All right.
So John, a couple things here as you're moving on. What you showed us, a lot of those, some of what we saw it's customizable, right? Like, so the response, you chose, I don't know the answer to this, but I can, I'll check with an expert. You can make that whatever you wanted, right?
Absolutely.
Right. So you could customize it for your company. If you had a standard response that you wanted to use, you could certainly do that. And then another question I had is the confidence level. Can you adjust that?
Yeah, so in the flow, there was a step there that determined when does it need to go to an expert. I set it to 0.9. You could set it to 0.7, 0.8. You want to experiment with that and set it exactly the way you want it.
Awesome.
Cool. All right. So our last example here is what happens if there isn't a service that does what you want. And a common request we get, we have customers that do this. They'll be using Yammer as a social network, in this case. They've got a large corpus of information, and every message gets tagged. It gets hashtagged. So it's easier to find later on. You can click on the hashtag, you can search on it, et cetera. And they've done a good job. What we've done is train a model so that it can respond in that organization's language automatically and intelligently. All right, so let's have a look at how that works. So we go down here to the auto classifier demo. We're going to come down here, and I've got some, again, you don't want to see me type. I've got a couple of questions we're going to ask of this thing. Or there's a couple of things to add to the network. So please welcome Stacy to the network. She started on Monday. That's a pretty common one. I'm going to go ahead and post that. And I've got another one. John. My mouse always works really well when I'm on stage. That's the best. All right. So let's come in here and punch something in here. And this is a little longer a message. Check out this awesome video of our employees volunteering across the globe for the 2018 Special Awareness Day. And do you see what just happened while I was typing that in? Stacy's message got replied to with a hashtag joined. So this model is trained with certain words, but basically every time they have someone come to the network, they use the hashtag joined. All right? And this hasn't responded yet, and that's fine, because I'm going to come back over here to flow. Just again, show you how that runs. And come into run topic detection. It's very, very straightforward. When there's a new message in a group, we check to see, this one's a little more complicated a formula, you don't get the UI around it, but it's part of flow. We basically check to see if it's been tagged already. And with Yammer, the entire thread gets tagged, not just any individual messages. If it is empty, in this case it's an HTTP service, we don't have a built-in action to call machine learning models yet, but you do get a web service. And you can call the web service from flow. So it's not, I'll still say this isn't coding, it's configuration, but you just have to have the right keys. So you can call that guy in, and you pass the body of the message to the API. What you get back is a blob of JSON data. It's easy enough to parse. You can actually you run the test, get the JSON back, punch that into flow, and it generates this. So you don't have to type any of this stuff in. And then, finally, go ahead and post a response to the original message with a hashtag, which of course hashtags the entire thread. Well, how was that built? How was that put together? This is using Azure Machine, and I should pop back to Yammer to see. Yep, there we go. It got flagged with hashtag corporate citizenship automatically. So you can see these are two terms. Joined is pretty generic, but corporate citizenship is particular to this particular organization, right? To do that, we had to build a machine learning model. This is a web-based tool that you can go to and to build one of these models. And my UI is going to be fun on me, so I'm going to, okay, So hopefully you can see this well enough. And if I doubt here anybody's used SQL Server integration services before. If I'm talking to data people, I can say it's a lot like that. But it's a visual interface. You add data to it, and then you can just start dragging things onto the design pane. It takes a little bit of learning, but it's not bad. And again, you won't have to see any code here. For example, I'm on the predictive experiment. I need to go over here to the training experiment. Building the model is actually fairly straightforward. To start with, we gathered up a corpus of information using our tygraph product. If you use our tygraph product, you have access to all of the data. And we grabbed the list of topics and thread messages and bundled all of that stuff up and create a data set from it. In machine learning, you just upload the data to it. You then decide exactly what you want in your data set. And for example, I'm just going to open this up. I'm going to visualize that. And you can see there's a body of message and some topics with it. So it's simply 2 columns of data. We can clean missing data. So any rows that are empty or any columns that are empty. We pre-process our text next. It's an action we drag on and say, I want to pull out HTML codes. I want to remove certain stop words. It's just a checkbox item. This one's the more complicated one for text analytics. We're doing something, I'm not going to get into the details of it, but you can look it up on Google just as easily as I did. Because I'm not a data scientist here, let's be real clear. I'm a data guy, but I'm not a data scientist. But what you're doing here is you're separating the body of the message into groups of 3 words. So the first 3 words, and the second, third, and fourth, and the third, fourth, and the fifth, etc. And you're looking for combinations of those terms and their frequency in particular topics. That's fundamentally what we're doing. So this step breaks it down. And this model here, this multi-class logistic regression, is one of those 5 types of algorithms you saw from the cheat sheet earlier, okay? We punched that into this train action, but before we do that, we split the data because we're going to use a portion of the data for training and a portion of the data for testing. And the split's usually 70-30, but you can pick. So we split the data, we train the model, and then we score the model with the remaining data that we didn't use for training. So it's essentially, this is what I'm saying, we've got these tools that are just designed to do this. It's been a common process in machine learning, but we haven't had the tooling that's really enabled it. And at the end, we can evaluate our model. Let's have a look at the results of this particular model. Come on, visualize. There we go. And you can see up at the top, you can get into details for a specific term, but you can see at the top, we're about 71% accurate on the remaining data from the training set. So that's going to be good enough for our purposes, and we can go back and correct things, but at least we're not missing anything by default. When we're ready, we create a predictive experiment by punching in set up a web service. That creates this predictive experiment tab here. It's just a variation of the same thing. And when we're ready there, we deploy that web service. That web service looks a lot like this. So we could test that web service. And let's see, Control A, Control V. There's that same term I just punched in. We can use the interface that's available in Azure to test out. You can see that topic for that sentence came back with corporate citizenship. All right? So it's doing the same thing. The UI around the web service allows you to go in and get the keys and everything you need to plug into Azure, and away you go. So really, it doesn't take an awful lot of effort to not only extract that knowledge from your social network, but to help you start to build it over and over again. And I believe, that's the end of the demos. How are we doing on time? Perfect. All right, so I'm going to flip back to the slides now. Number 5. So I'm going to reiterate what you saw there from an architectural standpoint. The Twitter example you saw there before with Power BI. How does that work? A new tweet goes out there. Flow knows enough to pick up on it. Passes that off to cognitive services, text analytics, sentiment analysis. You get a number back. We then pass the entirety of that data into Azure SQL. and on a periodic basis, a process runs to update the Power BI model behind this, and we can build a report from it. Fairly straightforward, right? The automatic image identification. Here we are in Teams. User uploads a file to Teams. That file gets stored in SharePoint. There's no trigger option for Teams right now. This is why I'm doing it this way. The trigger runs on SharePoint. Flow passes that now off to the computer vision service, image classification. That simply kicks back the caption and the tags, and we update the file in SharePoint. It's just, in this case, surfaced in Teams. Okay? Same idea for our custom vision example. The only thing is we're using the custom vision service, and we're looking for slightly different things, and we've trained our own model. All right? Q&A integration is a little more complex. With Q&A in Yammer, we post a message that has a question mark in it. Flow picks it up, passes that off to the Q&A service. Q&A service then kicks back a high confidence answer. We just answer it. We reply to it in Yammer. But what happens if that answer isn't high confidence? In that case, we pass a temporary answer to Yammer, we're not sure about this. And at the same time, it starts an approval. And it sends what it thinks the answer is down to an expert. The expert can do one of two things. They can approve it. If they approve it, the question gets updated, and then the question gets added to the Q&A service for that same answer. If the expert doesn't like what it kicked back, they reject it with the new answer. In that case, the new answer gets added to Yammer, and both the question and the answer are added to SharePoint, that SharePoint list, and another flow goes ahead and adds a new item to cognitive services. I'm not trying to prescript the way that this should work in your environment. This is just how what you just saw worked. I don't know that I would implement this in production. This is a proof of concept here, but in any event. And then finally, automatic topic prediction. That's fairly straightforward too. We add an item into Yammer. Yammer calls out to our Azure ML web service. It kicks back a topic for us, and we update the Yammer item. In this case, on a periodic basis, we need to have the discipline to go ahead and retrain our model on a periodic basis. As terms change, as we add things into our lexicon, you're going to want to keep that up to date. But again, we're using machine learning in a machine learning way. And with that, I'm going to...
Sure, and as we wrap things up here, today what we've done is we've talked about how sticky knowledge is, how difficult it is. We talked about how we're all doing a really pretty good job with our social communities of harnessing the knowledge of employees, and with the technology that John showed you, we're getting the ability to pry that knowledge out of the social communities and develop knowledge-based communities. And with that, we would love to say thank you once again and take questions if you have them.
Bring them on. Any questions? Would you mind coming up with the mic, sir? Thanks.
Hey, first off, thank you for putting the tygraph Twitter tool together. We use it for the Microsoft tech community. We use it for a lot of our social media handles. You guys have probably seen it live on Twitter. It's a very valuable tool the community loves. In this proof of concept, would it have the ability to analyze two parts of an ask? So if we were to bring in all of the conversations that were happening across a community, a lot of people who manage communities have an issue of executive teams and senior leadership teams want to see cool use cases that come out, but there's way too many conversations for community management teams to parse through those. You know, it could be thousands or hundreds of thousands of conversations. Could it tag something as a use case and then also search within a product tag so that we could say, oh, what's a cool use case on this new product, and maybe even define a role with that? So let's say an MVP like yourself, where we could have a cool story that happened in the community around a particular product within a certain identity.
Yeah, I'll take it first. That's, first of all, thank you very much for the compliment on our tygraph for Twitter product. I don't know if you saw it, but we're over 1 billion impressions, which is pretty impressive for this conference. Thank you for the question. So just to parse that question out a little bit, I believe what I heard you say, sir, was you're talking about a cool use case for a product, and you also happen to hashtag it, and together, that would be something that we'd want to bring to the attention of like somebody on the C-level or maybe somebody ahead of product to say, look at this. A couple of things that could really help is effective hashtagging, and then something we didn't talk about really today, which is concept searching, right? So that could be something we could use.
Yeah, there'd be a variant of it would be a custom model. It'd be a variant of the one you saw there. You could have multiple. It doesn't have to just be something that's prefixed as a hashtag. You could look for. You could also do a multi-step example. Is this about a product or not? Right. That's a yes, no. And then beyond that, if it is about a product, which product? Those would be two probably models that you would train. It'd be fairly straightforward to do, I should think. And then you could automate based on that, or at least hashtag in the social network with that, and then you could have something else run. Say, hey, whenever I see that hashtag, go off and alert somebody.
I think you're onto something. That's a really great idea, to laser into a particular conversation that's important, bring it to the top, and share it. So that's a great example.
That'd be in real time. Yeah, that's excellent.
There's another question over here.
Yeah, sorry.
Yes, where do you get the data from to train your model?
That data, so the example you saw there before, we're using our tygraph product for Yammer. The way we do it, we pull all the data out of Yammer and store it in a data warehouse. Again, you need the data to be able to do any training. So in our case, we're lucky. Well, no, we designed it that way in the first place, but yeah, you wouldn't be able to really point this straight up at the Yammer API. You'd have to go through if you didn't use us, you'd have to go through a bunch of genuflections to export it. But in any event, you need to have the data that you're using to build the model. That's a good question.
Great. Other questions? All right, let us thank you one more time. Safe travels back to where you came from, and thanks again.
Thanks for coming to Ignite.